Hello, ladies and gentlemen, and everybody in between. Our names are Michael Spoljaric and
Rafin Kabir.
And in today's video, we're going to be talking about the topic of mitochondrial DNA. We will be explaining the whole topic of mtDNA and how it relates to all of our ancestral history. Mitochondrial DNA, otherwise known as mtDNA, is a small chromosome found inside the mitochondria. The mitochondria being cellular organelles within the eukaryotic cells that convert chemical energy from food into ATP, ATP being adenosine-triphosphate. mtDNA spans about 16,500 DNA building blocks, otherwise known as base pairs, representing a small fraction of the total DNA cells. mtDNA comes from an egg, only from one bloodline, whereas nucleus DNA is the entire species. Now, I'm not going to sit here and lie to you. The human evolution as a whole is a very lengthy and complicated process, but I'll explain it to you. Within that process, we've changed from ape-like ancestors to more modern humans, like how we see to this day. The full human evolution took approximately 6 million years for us to go from our ape-like ancestor friend here to our modern-day human you see here. Throughout this evolving period of time, our ancestors not only evolved physically, but also behaviorally, whilst evolving over time due to the nature of our actions as well as our environment. SNPs, otherwise known as single nucleotide polymorphisms, people usually call them SNPs, are the most common type of genetic variation among people. SNPs usually occur around 1,000 nucleotides on average, and there are 4 to 5 million SNPs in an average person's genome. Most commonly, SNPs are found in DNA genes, and they act as biological markers, helping scientists locate genes located with the disease, which can also be used to find somebody like you and use your SNPs to find matches in your SNPs with a common ancestor from millions of years ago.
Race. It's a major buzzword we often hear nowadays. However, race isn't real. According to biological studies, race isn't etched into our biology. Rather, race is a social construct made to categorize people, mainly using the color of their skin. However, we are able to find out the differences between these races we have been assorted to. Using partial mitochondrial DNA from modern-day humans of different races, we can compare them using AI to find out how different or similar they are. In this scenario, we have 6 individuals from Africa, Europe, and Eastern Asia, respectively. An individual from Asia compared to an individual from Africa have the least similarities, being less than 80% similar to one another. However, an individual from Africa and Europe are the same percentage, with 2 individuals from Europe being at 98.90%. These differences are mainly due to how much time we spend in these locations, the longer leading to less similarities as our mitochondrial DNA mutates.